So let's solve this question. Consider a vector u bar is equal to 2x cap plus y cap plus 2z cap, where x cap, y cap, z cap represent unit vectors along the coordinate axis x, y, z respectively. The directional derivative of the function f of x, y, z is equal to 2 ln xy plus xy ln xy plus 3 ln xz at the point x, y, z 1, 1, 1 in the direction of u is dash. Okay, so let's see. Given f is equal to, okay, so f of x, y, z, for example, so f of x, y, z is equal to 2 ln xy plus ln yz plus 3 ln xz. So this can be completely written as, so you can take this 2 onto the top here and this 3 onto the top, but this is again a product. So ln of x square yz into xz whole cube, of course. So this is ln, let me write this also as a similar fashion. So ln yz is there, but into this. Okay, so now you can see x square into x cube, x to the power 5, of course, then y square into y cube, then z into z cube, z to the power 4, of course. Okay, so this is the function. Because it is slightly manipulated, calculations would be easy. Now you can see the directional derivative, correct? They have asked the directional derivative. So the directional derivative of f of x comma y comma z at point P in the direction of u is nothing but gradient of that function f at point P divided dot producted with u cap, of course. Okay, so dot producted with u cap. So if you want to calculate the derivatives, so first of all we have to calculate gradient of f. So considering grad f, okay, or you can write this point P completely. Okay, so this calculated at point P, of course, at point P, this is what you can say. So considering gradient of f, so grad f is equal to, differentiation of this term gives you 5x power 4 I cap or x cap, let's say x cap, then after plus 3 y square y cap, because x cap, y cap, z cap are the unit vectors, then 4 z cube z cap, this complete term divided by x power 5, because if you take logarithm you'll get x power 5 y cube and z power 4. This is the gradient of this function, correct? Because differentiation of this function is log is 1 by x power 5 y cube z cube, and you have, oh sorry, I'm sorry, we have some small correction here. So maybe I'll do it in the next page because the spacing here is a bit less. So considering grad f, considering gradient of the function, scalar function, so this would give us 1 by 1 divided by, okay, so 1 divided by x power 5 y cube z power 4, x power 5 y cube z power 4. Then if you differentiate these functions with respect to x, y and z, we have 5x power 4 y cube z power 4 x cap, plus then with respect to y we have 3x power 5 y square z power 4 y cap, plus with respect to z 4 into x power 5 y cube z cube, okay, z cap. This is the unit, this is the gradient of the scalar point function. Then u cap, so what is u cap? Of course, u cap is equal to u divided by magnitude of that particular vector. So what is u? Of course, here 2x plus y plus 2z. So if you calculate the magnitude of this, we have root of this is a constant vector, of course, right? So the magnitude is 2 square plus 1 plus 2 square, which is 9, of course. So square root of 9 is 3. So 1 by 3 times of 2 x cap plus y cap plus 2 z cap actually here. Okay, now if you calculate that dot product, therefore gradient of f dot u cap at 1 comma 1 comma 1 is equal to, so first of all this 3 and this scalar function, they come out as constants, 3 times of x power 5 y cube z power 4 into, now dot product of these two vectors gives you 2 times of this 10 x power 4 y cube z power 4 plus 1 times of this guy 3 x power 5 y square z power 4 plus 2 times of this term 8 x power 5 y cube z cube. So this complete expression you have to figure out at 1 comma 1 comma 1, of course. Okay, so if you do, then ultimately this is 1/3 times of then 10 plus 3 plus 8, which is of course 21, and this value is 7. Okay, so this is 7. So therefore the term changes at a magnitude of 7. So therefore directional derivative of f in direction of u at 1 comma 1 comma 1 is 7. That's it. Okay, so that's it. It's a simple question, but of course we have to just do the calculation slightly effective. That's it. Okay, so 7 is the correct answer, which is in here option C. Okay, so 7 is the correct answer with this the dot product of gradient with the unit vector. That's all. Thank you.